progressing any further. Number of breeding females in an endangered population of gorillas is G0. Biologists predict that the number of breeding females in N years' time will grow accordingly that much. There are currently 28 breeding females in the colony. Find G0. So currently, meaning before they have started to evaluate anything. So currently kind of is the same thing as initially. Now we know what initially means. That means my time, whatever it is equal to 0. In this case, my N is equal to 0 because we're using years. So if I substitute that in, G of 0 equals, now I don't know what G0 is, but if I do 1.01 times the power of 0, it should equal to 28 breeding females because that's currently my situation. So anything to the power of 0, well, that goes to 1. So basically what it's saying is, therefore, G0 is 28, is basically what they are giving us. So initially they have 28 breeding females. Okay. So G0 doesn't have necessarily a unit, so I'm just going to leave it at 28. Right, let's do BI. Find the predict the number of breeding females after 5 years. So my N is 5. So that would be just substituting it in. So 28, because I found out G0 is 28, times 1.01 to the power of 5. That approximately gives me 29 females. I should really like breeding females. N is 10, that means G to the power of G and then 10. 28 times 1.01 to the power of 10, which is approximately 31 females, or breeding females. N is 20, so therefore G, 20. Chuck it in your calculator, that becomes 34. Okay, so now all I have to do is sketch it. Well, hopefully we're used to sketching it by now. Let me label my axes first. So my G population is females, breeding females, and N is in years. Alright, so my smallest amount that I need to get through is 28 and 34 females, so I just need to make sure I can get that in. So I'm just going to maybe do 2, 4, 6, 8. No, I'm not going to fit it in. So I'm going to go 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. I should be able to fit them in. And then I'm going to go 20, so I'm going to go 2, no, that's not going to work, 3, 6, 9, 12, 15, 18, 21, so that fits. So now I'm just going to draw it. So when G is 0, I have about 28. So that's about here. When G is 5, or sorry, my N is 5, my G is 29 females, so it goes up by a little bit. That's at 6, hold on. Approximately here. And then my N is 10, and then 31 females. And then 20 is about here, and then 34 females, so it goes up by a little bit. So this is a very little exponential graph because my scales are not as good, but it still doesn't jump. Make sure you write my equation. G equals 28 times 1.01 to the power of N, and then you're done.